lethargic response to the hormone, resulting in higher blood glucose levels and more insulin needed for vital metabolic functions. C-peptide lab tests, which measure circulating insulin levels in the body, show Louisa's resting levels of the hormone to be as much as 3 times as high as Colby's at the time of his emergency. At first glance, Louisa's body appears to have adapted brilliantly to compensate for this aberration, enabling her to regularly run ultramarathons. But if you look more closely, another picture emerges. Even with all her running, Louisa has not been able to shake off her excess weight, nor her foggy spells of depression. In the case of Noam, who has type 2 diabetes, his pancreatic islet cells have to generate 6 times the normal amount of insulin to help him get through his 12-hour workday. Noam's body's impaired response is called insulin resistance. Consider the following statement to be one of the 10 commandments of biology. All the body's vital mechanisms, varied as they are, have only one object, that of preserving constant the conditions of life in the internal environment. It was made by a vintner's son and one-time vaudeville playwright, who later discovered a passion for medicine. Born in the village of Saint-Julien-en-Beaujolais, Claude Bernard, 1813 to 1878, was recognized in his lifetime as one of the giants of science. Bernard created the notion of the milieu intérieur. His observation about the need of complex organisms to regulate a stable internal environment in the face of a sub-zero climate, a viral pandemic, or a heart-pounding 2-hour dance led to neurologist and physiologist Walter Cannon coining the term homeostasis. Insulin is the primary controller of energy homeostasis in the human body. As it permeates the variegated landscape of virtually every type of human cell, its range of actions is exquisitely regulated and highly differentiated between bodily organs. When insulin resistance causes signaling defects and clutters the intracellular pathways in the body and the brain, the effects are compellingly wide-ranging. For nearly 800 million years, insulin, this pearly-chained hormone, the simultaneously most studied and most mysterious molecule in medicine, and its precursors, enabled living organisms to store energy for times of food scarcity or for sudden energy needs. Insulin resistance is an evolutionary form of energy conservation that enabled our Paleolithic hunter-gatherer ancestors to survive periods of food deprivation by signaling the body to store fat instead of burning glucose as energy. In our post-Neolithic age of nutritional plenty, adverse stress patterns, deficient exercise, and reduced sleep, this inherited genetic adaptation, which affects 1 in 4 people, has resulted in a range of metabolic imbalances, so the body appears to have gone rogue. We, like others in the medical profession, daily witness this shift that represents a fundamental and growing change in human health as habitual insensitivity to insulin is passed from one generation to another. There is an added twist to this picture. In 1971, Tibor Ganti, a Hungarian biochemist and the author of The Principles of Life, observed that our body's regulatory mechanisms depend on an internal-external gathering of clues. The metabolism is a unit of life. It is inherently stable. It contains an informational subsystem, and it is regulated and controlled. In this instance, a genetic adaptation for survival has created the possibility that the body's tightly controlled glycemic control system can be bypassed. Externally, culture, lifestyle choice, is the enabler, both for exacerbating the symptoms of insulin signaling defects, but importantly, also offers pathways for its correction. Our patients did not realize that because of their diminished response to a dominant